Find the x and y intercepts, the vertical asymptotes, and the end behavior. Then use this information, along with a sign chart and a couple of additional points, to sketch the graph of g of x equals 4 over x squared minus 7x plus 10. We'll start with the y-intercept. Remember, we find the y-intercept by evaluating the function at 0. When x is 0, the two terms with x in them become 0, and we're left with 4 over 10, which reduces to 2/5. So the y-intercept is y equals 2/5, which is just less than 1/2. So it's going to go right about there. Next, we know that the x-intercepts occur when the function is equal to 0, and for a rational function, this happens when the numerator equals 0. However, the numerator is 4, which is never equal to 0, so what that tells us is that there are no x-intercepts for this function. Next, we'll move on to the vertical asymptotes. To find the vertical asymptotes, we need to know when the denominator is equal to 0. So we need to figure out when x squared minus 7x plus 10 is equal to 0. We can factor this by unfoiling. We need two numbers that have a product of 10 and a sum of -7. Those numbers will be -2 and -5. And then each of these factors corresponds to a 0 of the polynomial, specifically x equals 2 and x equals 5. So at x equals 2 and x equals 5, we're going to have vertical asymptotes for our graph. So I'm going to draw those with dashed lines, and I'm not able to do this perfectly because the iPad is a little slippery and the iPad pencil is a little awkward, but I'm doing my best, and I expect that you should be able to do just as good when you draw things out in your notes. So those are our vertical asymptotes. Next, we need to figure out the end behavior. Because the degree of the numerator is less than the degree of the denominator, we know that this automatically means we're going to have a horizontal asymptote at y equals 0, which is the x-axis. So we can draw in the horizontal asymptote as well. So now we've got all of our asymptotes with the end behavior and the intercepts. We need to use this information along with a sign chart and a couple of additional points to sketch the graph. So let's make our sign chart next. Remember that with the sign chart, our critical numbers come from the x-intercepts and the vertical asymptotes. Here, the vertical asymptotes are 2 and 5, and there are no x-intercepts. So those are going to be the only critical numbers. Now, the factors in our rational function, the numerator is just 4, and the denominator is x minus 2 and x minus 5, and these together give us g of x. So 4 is always going to be positive because it's a positive number. X minus 2 will be positive so long as x is greater than 2 and negative otherwise. And x minus 5 will be positive so long as x is greater than 5 and negative otherwise. So using our sign chart, we can see that the first interval will be positive, the next one will be negative, and the last one will be positive. Let's take a look at this first interval from -∞ to 2. Our function is always positive there, which means it's never going to dip below the x-axis. And so because it's also asymptotically approaching the x-axis and the line x equals 2, we know that our graph is going to have to go through the y-intercept and go up, asymptotically approaching that line, and then to the left, asymptotically approaching the x-axis. Now, of course, my graph is not going to be perfect. There's going to be a place where the distance between our curve and the asymptote is less than the width of the curve that I'm drawing using my iPad. So of course, it's impossible to draw this looking perfectly, and because I'm not a robot and I waver just a little bit, it's going to look like probably that my curve actually touches that asymptote. We know that's not the case, and all we can do is draw the best graph that we can and try to convey the things that we want to convey. Now, in the next interval between 2 and 5, our function is always negative. So that means it's never going to be above the x-axis on this interval. It's always going to be below. The only way that we can stay below the x-axis and be asymptotic to both of these lines is for the graph to be going up from the bottom and then curve and then go back down. The only question is, how high does the curve go? And one thing that we can do to figure that out is, or at least get an idea, is to pick a value of x in this interval to evaluate the function and get an idea of what it looks like. So let's pick 3 for our x value, and let's evaluate the function at 3. If we do that, the numerator is just going to be 4. 3 squared is 9, minus 7 times 3 is 21, plus 10. And so 9 plus 10 is 19, minus 21 is negative 2. So we've got 4 over negative 2, which is negative 2. So this gives us the point 3 comma negative 2, which is right there. And this tells us that we do actually go up a decent amount close to the x-axis when we're looking at what the graph does in between these two asymptotes. So it's going to look something like this. We don't know exactly where the local minimum value takes place, what the highest point is on this part of the curve, but we can get a decent approximation, and of course in calculus we can actually figure out what that value is. Now on the last interval the function is only positive, so it never goes below the x-axis. The only way this can happen while keeping the asymptotes is to start above, to go down, and then move over to the right. But let's get a point somewhere in here to figure out how close we actually get to this corner. So I'm actually going to pick 7 to see what the height of the function is there. So if we try 7, we're going to have 4 over 7 squared is 49, minus 7 times 7 is 49, plus 10. So we end up with 4/10, or 2/5. So we're going to end up being around right here, 7 comma 2/5. And so we know that we're going to be pretty close to that corner. And so our graph should look something like this. Of course it's not perfect. If we wanted it to be perfect, we would need to pick some more points. We would really need to do some calculus to figure out what the maximum value is on that part of the curve. But the process that we've gone through gives us still a pretty good idea of what this graph looks like, what the intercepts are, what the asymptotes are, what the end behavior is. So we have got a pretty decent graph on our hands.